Hello, my name is METİN arkadaşlar. This is 329th part of explanation of my theory. According to my theory and my formulas, you are wrong, physicists. Electron mass is not 9.11 × 10⁻31 kilogram. It is not constant. Compton shift is the proof. 1. The wavelength, radius, of an electron with a mass of 9.11 × 10⁻31 kilogram is 0.00242 nanometer. You say this Compton wavelength. But according to accepted physics theories, an electron is point particle without dimensions. This is dimensionless particle. This is wrong. 2. You cannot move. This is non-relocating electron, if you see. You cannot move an electron with a mass of 9.11 × 10⁻31 kilogram with an accelerating voltage between 0 and 515,702.4793 volts. Corresponding voltage is 0.00242 nanometer wavelength sized electron at rest. Point mass is 9.11 × 9.11 × 10⁻31 kilogram. Corresponding voltage is what? 515,702.4793 volts. I hope you see. Between 0 and 515,702.4 volts, you cannot move an electron with a mass 9.11 × 10⁻31 kilogram with an accelerating voltage between 0 and this value. You can only accelerate an electron of this mass with a voltage greater than 515,702.47 volts. How? Because that I put forth mine arkadaşlar's shortened wavelength of an accelerated electron, lambda normal minus delta lambda. When electron is accelerated, it gains velocity, and like this in 0 degree direction, its wavelength shortened becomes wavelength, shortened wavelength. Okay, this is my formula. The Einhorn formula is wrong. De Broglie formula is wrong. Compton wavelength formula is wrong. Okay, as I told you and as I explained you before, this is my formula. Lambda normal minus delta lambda. This is shortened wavelength is equals to 1248 nanometer voltage divided by applied voltage. Okay. Non-relocating electron with 9.11 × 10⁻31 kilogram with 0.00242 nanometer wavelength. Okay. Short energy is, or voltage is, according to me, As I explained to you, voltage is energy. Okay. 515,702.4 volts, 1.248 nanometer divided by 515,702.4 volts is equals to 0.00, the same, 242 nanometer. Lambda normal, if lambda normal minus delta lambda normal is equals to lambda normal, electron is still at rest. This means we cannot disturb this electron. We cannot make this electron gain velocity. The same, because shortest shortened wavelength, there is no shortest shortened wavelength. It is equal to lambda normal. Okay. We must apply greater voltage. When we apply a voltage of, for example, 520,000 volts to this electron, like this, okay, lambda normal minus delta lambda normal will be equals to 0.00, I'm so sorry, lambda normal minus delta lambda will be 0.0024, not 0.00242. Okay, this is lambda normal, 0.00242. Okay, lambda normal. This is now when we apply 520,000 volts, its shortest shortened wavelength, lambda normal minus delta lambda will be 0.0024 nanometer. Okay. This is our electron. In 0 degree direction, this is shortest shortened wavelength of it. Electron motion forms velocity. Okay. When we apply a voltage of, for example, 520,000 volts to this electron, we give it a certain velocity. Thus, the continuous spectrum, the continuous spectral band, like this is a band, continuous spectrum band, spectral band of this electron is revealed when we apply greater than 515,702.4 volts. For instance, when we apply 520,000 volts, okay, to this electron, free electron, we give it a certain velocity, thus the continuous spectral band of this electron is revealed. So important, please listen to me. And this band contains wavelength values between the initial at rest 0.00242 nanometer wavelength of the electron and its smallest wavelength 0.0024 nanometer. Here the smallest wavelength, shortest shortened wavelength of the electron, depending on the applied voltage and therefore its speed, is 0.0024 nanometer. Snapshot. From now on, please carefully listen to me. 4. A characteristic X-ray cannot occur. Spike. Continuous spectrum belongs to free electron motion form in motion, according to me. In motion electrons appearance indicators. Okay. and this is continuous spectrum, represents free electron in motion. Spike represents proton-bound electron motion from single wave pulse, characteristic ray, or say characteristic X-ray. May not be X-ray, characteristic lines, all kinds of characteristic lines, emission lines from proton-bound electron motion form. Okay. A characteristic X-ray cannot occur, this cannot occur without free electrons continuous spectrum. And here there is no probability. This is so important, please listen to me. This is proof that an electron has not 9.11 10 to the minus 31 kilogram. This is wrong. This is wrong. Electron constant mass 9.11 10 to the minus 31 kilogram mass. This is wrong. A characteristic X-ray cannot occur without free electrons continuous spectrum. And here there is no probability to be placed the molybdenum key alpha line with 0.0709 nanometer. There is no place for this because 0.00242 nanometer starting point and 0.0024 finishing point. Starting point this. You cannot place this value here if electron mass were 9.11 10 to the minus 31 kilogram. You wouldn't see 0.0709 nanometer spark key alpha molybdenum with this wavelength. Yes. And here there is no probability to be placed the molybdenum key alpha line with 0.0709 nanometer wavelength and its shifted versions in this band. Okay, in this band you cannot see 0.0709 nanometer key alpha from molybdenum cannot occur on this band as a spike. Okay. Since this wavelength band starts from 0.00242 nanometer, it is not possible for the molybdenum key alpha line 0.0709 nanometer and its shifted versions to be located here. It is not possible for the molybdenum key alpha line 0.0709 nanometer and its shifted versions to be located here. This is a clear evidence that the electron subject to Compton shift is not 9.11 10 to the minus 31 kilogram. This proves that the Compton shift occurs with electrons of smaller mass and larger wavelength. Like what? Like this. Lambda normal is 0.22 nanometer, not 0.00242 nanometer. Starting point. When we apply, okay, 20,000 volts, there is shortened wavelength, 0.0624 nanometer, between this band, continuous spectrum band, when single wave pulse from proton-bound electron, single wave pulse molybdenum key alpha line 0.0709 nanometer and its shifted versions can, when they coincide with free electron motion, forms waves, two different types light. When coincide, okay, when a kind of interfere, then at this point 0.0709 nanometer, yes, on this continuous spectrum, molybdenum key alpha line will be occurred. Then for not relocating 0.22 nanometer wavelength size electrons point mass C in the C